Hello guys, my name is Prince and this is Smart Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are beginning a new topic today, quadratic functions and graphs of quadratic functions. Here are the objectives that we look forward to achieving at the end of this topic. At the end of this topic, you should be able to factorize a quadratic expression. You should be able to solve a quadratic equation. You should be able to find a quadratic equation when the roots of the equation is given. You should be able to draw the graph of a quadratic function. And finally, you should be able to interpret the graph of a quadratic function. So in this topic, we are going to learn about quadratic functions and graph of quadratic functions. Let's begin with quadratic functions. Quadratic expressions are of the form as squared plus bs plus c, where a, b, and c are constants and a is not equal to 0. In quadratic expressions, the highest power of the variable in the expression is 2. Some examples are 2x squared minus x plus 1, q squared plus 4q, 4 minus 3y squared, and 5n squared. All these are examples of quadratic expressions. Let's learn more about quadratic expressions. In the video on Introduction to Linear Equations, we learned that in a linear expression, the highest power of the variable in that expression is 1. So, for example, the expression 3x plus 1 and the expression 4a minus b are linear expressions because the highest power of the variable in each of these expressions is 1. Let's consider the first expression, 3x plus 1. The variable here is x. The power of x is 1 because there is no power on top of it. We learned from the videos on indices that when you have a variable or number with no power on top of it, it means the power is 1. So here the power of x is 1. So in the first term of this expression, the power of the variable is 1. The second term is a constant. It does not have a variable attached to it, so it means that the power of the variable here is 0. So the power of the variable in the first term is 1 and the power of the variable in the second term is 0. Between 1 and 0, 1 is the highest. So we can say that the highest power of the variable in this expression is 1. When you come to this expression, that is 4a minus b, we have two variables. We have a and b. The power of a is 1 because there is no power on top of it. So the power of a is 1 and the power of b is also 1. So as we can see, we have two expressions a and b. The power of a here is 1. The power of b here is 1. So the highest power of the variable in this expression is also 1. Now, because the highest power of the variable in each one of these expressions is 1, we can say that these expressions are linear expressions. Now, let's apply the same thing to what we have here. Let's consider the first one, 2x squared minus x plus 1. This expression has 3 terms. The variable here is x. The first term is 2x squared. The power of x in this term is 2, so x has a power of 2. The second term is x. The power of x is 1. The third term is a constant, so it has no variable, which means that the power of the variable here is 0. So in the first term, the power of the variable is 2. In the second term, the power of the variable is 1. In the third term, the power of the variable is 0. So the highest power of the variable in this expression is 2, because between 2, 1 and 0, 2 is the highest. So we can see that the highest power of the variable in this expression is 2. Let's look at the second example. It has two terms. The variable is kill. The power of kill in the first term is 2. The power of kill in the second term is 1. So between 2 and 1, 2 is the highest. So in this expression also, the highest power is 2. Let's look at the third example. It has two terms. The variable is y. 4 is a constant. It does not have a variable attached to it, which means that the power of the variable here is 0. The second term is 3y squared. The power of y here is 2. Between 0 and 2, 2 is the highest. So we can say that the highest power of the variable in this expression is 2. Let's consider the last example. It has only one term, that is 5n squared. The variable is n. The power of n here is 2. So we can see that in each one of these examples, the highest power of the variable is 2. When you have an expression like that, it is known as a quadratic expression. An expression where the highest power of the variable in that expression is 2. For linear expressions, the highest power of the variable in that expression is 1. So if you consider this example, 4x exponent 3 plus x exponent 2 minus 3x plus 1, we can see that this expression has 4 terms. The variable here is x. The power of x in the first term is 3. The power of x in the second term is 2. The power of x in the third term is 1. The power of x in the last term is 0. The highest power here is 3. Because the highest power of this expression is 3, we can see that this expression is not a quadratic expression. Because for an expression to be a quadratic expression, the highest power of the variable in that expression must be 2. I hope that is clear now. So in quadratic expressions, the highest power of the variable is 2. This is the main reason why, if you consider the first point, we are being told that quadratic expressions are of the form as squared plus bs plus c. So this is the general form for a quadratic expression, as squared plus bs plus c, where a, b, and c are constants, and a is not equal to 0. Now this condition is very, very important. A is not equal to 0. If you consider the general form for a quadratic expression, that is as squared plus bs plus c, we can see that a is the coefficient of s squared. So a is the coefficient of the squared term. If a is equal to 0, then we will have 0s squared, and 0s squared will give us 0. So if a is equal to 0, this term as squared will no longer be in the quadratic expression. So we are going to have bs plus c. Bs plus c is not a quadratic expression because bs plus c does not contain a square term. So for this expression to be considered as a quadratic expression, a should not be equal to 0. This means that this whole expression, as squared plus bs plus c, I'm going to clean the ink here so that you can see clearly what I'm referring to. This expression, as squared plus bs plus c, is considered a quadratic expression because of the square term. So as soon as the coefficient of the square term is 0, the expression ceases to be a quadratic expression. So if we apply that here, we can see that if the coefficient of x here is 0, we will have 0 times s squared, which will eliminate this whole term. So this whole term will be 0, and we'll be left with 0 minus x plus 1, which will give us minus x plus 1. Minus x plus 1 is not a quadratic expression. In the same way, when we come here, the square term here is q squared. The coefficient of q here is 1. If the coefficient of q here is 0, you have 0 times q squared, and that will eliminate this whole term. So you'll be left with 4q. 4q is not a quadratic expression. The same thing applies to this example. The coefficient of y squared here is minus 3. If it were to be 0, we will have 4 minus 0 y squared. 0y squared will give us 0. So this whole thing will become 4. And we can clearly see that 4 is not a quadratic expression. In the same way, the coefficient of n squared here is 5. If it were to be 0, we will have 0 times n squared. 0 times n squared is 0. And this whole thing will turn into 0. And 0 is not a quadratic expression. So for an expression to be considered as a quadratic expression, the coefficient of the square term should not be 0. So in this expression, ax squared plus bx plus c, a should not be 0. B can be 0, C can be 0. Both B and C can be 0. It doesn't matter. But A should not be 0, because if A is equal to 0, then AX squared plus BX plus C is no longer a quadratic expression. As we can see from the examples that we have here, a quadratic expression can have one term, it can have two terms, and it can have three terms. If a quadratic expression has two terms, it is called a quadratic binomial. In the videos on algebra, we learned that a binomial is an expression with two terms. So if a quadratic expression has two terms, it is called a quadratic binomial. If it has three terms, it is called a quadratic trinomial. So in these examples, example 2 and example 3 are quadratic binomials, and example 1 is a quadratic trinomial. In the next video, we are going to learn how to factorize a quadratic trinomial. We learned how to do that under algebra, so we will solve a few examples to refresh our memory. Thank you for watching this video. Subscribe to this channel for more videos. As I've already indicated, in the next video, we are going to learn how to factorize a quadratic trinomial. Bye-bye.